Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. So over the next few lessons, we're going to learn about similar triangles. Now, when we're solving problems with similar triangles, sometimes certain angles, like, vertically opposite angles, angles in parallel lines, sometimes they come up. So it's important that we know what these are. So before we get to similar triangles, we'll have a review of angles and triangles. So we'll start off with angles. So here I've drawn two lines that are parallel, so usually these arrows are drawn to indicate they're parallel. So of course that means these two lines will never meet if they went on forever and ever. So when we draw a line that crosses those two lines, we call that a transversal. So I'll draw one of those. So it goes across like that. Now, there's special properties of all the angles that we have here. So this angle here, let's say it was about 75 degrees. May not be drawn exactly to scale. So hopefully you remember that angles in a straight line, like that one, equal 180. We call the 75 degree angle and this angle I've marked with an X, we call those two angles supplementary. That means they add to 180 degrees. So if this angle here is 75 degrees, then the angle I called X must be 180 minus 75, which is 105 degrees. So those angles are called supplementary. So that's angles of a straight line. Now, if this angle and this angle add to 180, but this angle plus this angle are also in a straight line, so they must add up to 180. So this angle here must be 75 degrees as well. So this angle and this angle are always equal. They're vertically opposite angles. So vertically means like they're standing up, and opposite means facing each other. So this angle, the fourth angle here, that will also be 105 degrees because it is vertically opposite to this angle. And that's just because of supplementary angles. So vertically opposite angles are always equal. So now we need to look at more angles with the parallel lines. Well, it turns out that supplementary angles aren't just angles in a straight line. It turns out that this angle here and this angle that I've just marked are also supplementary. They add up to 180. So these two angles make a C shape here. So that C, and both of them are inside the C, means co-interior angles. So the two angles that I've just marked are supplementary. They add to 180 degrees, and we call them co-interior angles. So, of course, if the first angle is 105, this angle here must be 75 degrees. So those angles co-interior, now they're not equal, they are supplementary, add to 180 degrees. Now, because this angle and this angle add to 180, but this angle and this angle must also add to 180 because they are supplementary angles in a straight line, then that means that this angle here and this angle must be equal to each other. And you can see that these two angles form, and I know I didn't draw it that well, these form a Z shape. And the Z shape angles are equal. We call them alternate because they are on alternate sides of the transversal. They're also called alternate interior angles because although they're also on opposite sides of the transversal, they're both inside the parallel lines. That's where we get interior. So this angle is 105 degrees. And so co-interior was the C shape, alternate is the Z shape, and alternate angles are equal. It can be a back to front Z or a forward Z, okay? So they look like this. Same with co-interior, as well as being a proper, like facing C, they can be a backward C, and it would be these two angles that are co-interior. So these angles, co-interior and alternate, they only work for parallel lines. If the lines are parallel, then alternate angles are equal. If alternate angles are equal, then the lines are parallel. But if the lines are not parallel, alternate angles won't be equal. So it's important that alternate, co-interior, you know that works only when we have parallel lines. So by all of this, we have another pair of equal angles. You might see that this angle here is equal to that angle, and this angle is equal to that angle. Now that is no coincidence. That always happens with parallel lines as well, because this and this add to 180, and this add to 180. The only way that can work is if we have this angle and this angle being equal. So they're sort of bounded by an F shape. Now this is like an upside down F, but that's okay. So upside down F can be this way or this way. It can also be that way. These are called corresponding angles. So like that. So they're actually not both interior. One's like inside the parallel lines and one is outside the parallel lines always. Okay, so the F shape are called corresponding angles, and they are also equal. They're always equal when we have parallel lines. So the ones that I've written in red, corresponding, alternate, and vertically opposite, they are all equal. Vertically opposite angles, alternate angles, and corresponding angles are equal. Of course, alternate and corresponding angles have to involve parallel lines to be equal. The ones I've written in blue are supplementary. They add to 180 degrees. The ones I've underlined rely on parallel lines to be supplementary if it's a co-interior angle, or equal if it's an alternate angle. So make sure you know them because they do come up when we're talking about similar triangles. So now we're going to look at the different types of triangles. So please pause and copy this down if you need. So we can classify triangles two ways, and you need to know how we classify them both ways. So firstly, we classify triangles according to their angle properties. Now remember, in any triangle, doesn't matter how weird it looks, if it's a shape with three sides, the angles inside add to 180 degrees. So there are sort of three options for the angles. They can either be all acute, so all the angles are acute. You can have one right angle, or you can have one obtuse. Remember, of course, obtuse means more than 90 but less than 180 degrees. So they are the three options. For every triangle, one and only one of these will be true. So if all angles are acute, we just call it an acute angled triangle. You've had some experience with right-angled triangles before. If we have a right angle, we call it right-angled. And if we say an obtuse angle, we don't mean, of course, that all the angles in the triangle are obtuse. That's impossible. You can only have one obtuse angle. We call them obtuse-angled. We also classify triangles according to their side properties. So we're talking about how many equal sides they have. So they could have no equal sides. So that would mean all sides are a different length. That is a scalene triangle. They could have two equal sides, and we call that an isosceles triangle. And they could have three equal sides. All sides could be the same length, and we call that an equilateral triangle. Now, because the angles inside a triangle add to 180, and there is this phenomenon that the number of equal sides is the same as the number of equal angles. In any equilateral triangle, all angles are 60 degrees. So an equilateral triangle is always acute angled. But an isosceles triangle could be right angled, acute angled, or obtuse angled. A scalene triangle could be acute angled, right angled, or obtuse angled. Okay, so let's look at a triangle and go ahead and classify it. So the triangle that I have drawn here, you can see that there are two sides equal to 4 centimeters. So straight away I know it's isosceles triangle. So there is an angle that is 97 degrees. So 97 is obviously more than 90. That's an obtuse angled. So we have an obtuse you can just write obtuse isosceles triangle. Okay? Note for isosceles triangle, if they have two sides equal, for any triangle that has two sides equal, it will also have two angles equal, and they will be the base angles, where each of the equal sides hits the base, okay? So obtuse angles have two equal sides, they also have two equal angles. Scalene triangles have no equal sides, they also have no equal angles. And equilateral triangles, three equal sides, they also have three equal angles. So let's just try one more question. Please pause and copy this down if you need. So let's have a go at this question here. I have a triangle, one angle is 70 degrees, one angle is 40, and I want to know what type of triangle it would be. So let's first figure out the third angle in the triangle. So the size of the third angle would just be 180 minus 70 minus 40. The reason for that is that the angle sum of any triangle is 180 degrees. So if I had a triangle like this, and I said this angle was 40, this angle was 70, the third angle must also be 70 degrees, right? So what I notice is that I have two equal angles. That means I must have two equal sides. So therefore, the triangle is isosceles. As you can see, all angles inside the triangle are less than 90 degrees. Therefore, it is an acute isosceles triangle or acute angled isosceles triangle. Alright, hope you've learned something from this video. This has been the luckiest maths teacher in the world. Have a great day.